Hi class, welcome back. In this video, I'm going to be in our studio going through some code, and actually I will be doing some coding on the fly. So the last video introduced you to ggplot. In this video, I'm going to show you some different types of plots we can make. I'm going to specifically show you how to make 5 different types of graphs. The authors of Modern Dive, the textbook I use in my intro stat course, refer to these as the 5 named graphs, or 5NG. And they're a great starting point. So the first one we're going to look at is a scatter plot. We already saw one example of this in the slides where we plotted the cumulative weight in pounds by date. So there's the code. And when I run it, there's my plot. Another way, maybe what's more common, we use scatter plots, is to examine relationships between 2 quantitative variables. So I'm going to use a different data set now, the penguins data set. And we're going to plot the bill length versus flipper length for the Palmer penguins data. So I'm going to go ahead and start with my data set. And I'm going to pipe. And just so you know, I did the shortcut Control-Shift-M to do that pipe. And I will ggplot. I'm going to put my aesthetic right in there. On the x-axis, we're going to go ahead and put the bill length in millimeters. And on the y-axis, we're going to put the flipper length in millimeters. And then I'm going to add a layer. I'm going to add g_point, which will produce the scatter plot. Notice it tells us that it removed 2 rows containing missing values, so we know that there are some missing values in there. Always good to take note of those warnings and messages. After creating the plot, we should interpret the plot. For scatter plots, we'll usually describe the direction, form, and strength of the relationship. So in this example, there looks to be a positive, linear, moderate relationship. So direction is if it's positive or negative. The form is, linear or something nonlinear. And the strength sort of describes how tight the points are around that, line or curve you might envision. One way we can easily add another dimension to this plot is by mapping another variable to color inside the aesthetic. So now we'll try mapping species to color. Now, I'm going to go ahead and write the whole code out again, although I could have copied and pasted some of this. So on the x-axis, I have bill length. And on the y-axis, I have flipper length. And then I'm going to add another aesthetic. Now, just to make this code look a little nicer, since it's getting long, I'm going to go ahead and put it on another line. So species. So now it is going to map species to color. And I'll again do g_point. And notice how this changes our plot. Now we have colors. The points are colored by species, and this legend has been automatically added to our output. Okay, moving on to the line graph. Line graphs are most often used to show data over time. Let's go back to the garden data. Originally, we plotted it using points, but it might be better to do a line graph. So I'm going to go ahead and take that harvest data and pipe into ggplot. So ggplot will use that data. I can right away start with my aesthetic. So on the x-axis, I will put date. And on the y-axis, I will put, I forget what the variable is called. So I'm going to go ahead and go up to my data set. And it is called weight pounds. Okay. And now instead of doing geom point, I'll do geom line. Great. We could also do both a line and a point. So I'm going to go ahead and copy my code because I don't want to type this all again, and paste it into here. So I'm going to do a geom line and a geom point. Because I have my aesthetic mapping in ggplot, it will be carried through to both geom line and geom point. So there are occasions where this might be a better option. And I just want to show you really quick, in case I forgot to do this, and let's say I just put the aesthetic here, it now returns an error because it doesn't know what aesthetic mapping to use for geom point. Okay. So I'm going to go ahead and put that back in ggplot. After plotting the data, we should describe any trends or patterns we see. In this case, we see that the cumulative harvest is increasing at what looks like an exponential pace. Don't worry, that'll stop come October. Let's also see how adding color to a line graph can be useful. The summary veg data, I think I wrote that wrong. No, summary veg date, that's right. Data set has a row for the weight in pounds by vegetable by day. So let's just take a quick gander at that data. There it is. So on each date, there's a row for each vegetable that was harvested that day. Oops. If we try creating a line graph like we did before, it is going to look like a mess. So let's say I take that data and then do my ggplot. My aesthetic mapping will be X is date, Y is, I already forgot the name of it. Weight. Okay. Y is weight. And if I just try doing a geom line, this is going to look terrible because there's multiple vegetables being harvested each day. So this is why we're getting these long points up here. What I really want to do is add something to this plot, and that is I want to map color or map vegetable to color. So let's try doing that. Now that looks a lot better, but you might agree that this plot could still need some work after this point. There's a lot of colors. So we might think of some other ways to improve that further. We're going to save that for another time. Let's move on to histograms. Histograms show us the distribution of a quantitative variable. That is, what values that variable takes and how often. Let's look at the distribution of body mass in grams for the Palmer penguins. So again, I take the penguins data set and then I ggplot it. I'm going to map body mass to the x-axis. And in this case, I don't need any other aesthetics. It is going to create one for me. So it is automatically putting count, like a frequency, on the y-axis. So for each bin, this is how many observations fall into each of those bins. When we look at histograms, we want to describe the shape, center, and spread of the data. So this shape is slightly right skewed, meaning this part on the right side is a little bit longer than the part on the left side. The center is probably a little to the right of 3,500. And, you know, to give a very generic spread out measure, we might just give The range is around 4,000, going from a little over 2,500 to a little less than 6,500. I will show you later how to calculate some better statistics for this as well. When we create histograms, we always want to try varying the number of bins just to see how that changes the graph. So I'm going to go ahead and copy and paste this code. And inside the geom histogram, I'm going to add bins equals. The default is 30. So let's try doing something a lot smaller, maybe 15. So that certainly takes out some of the ups and downs. This might be a little too smoothed out. And let's try doing something a lot bigger. Let's say we'll double it. Let's do 60. So here I now am seeing too many peaks and valleys, I guess. So I think in this case, it's good to stick with right around 30. The other thing we want to do is be careful when using color as an aesthetic. So mapping a variable to color in this case. By default, it will show the original histogram with the coloring reflecting the proportion of that level. Also, color changes the color of the outline. If you want to change the inner color, we need to use the fill aesthetic. So in this code, I've mapped sex to color, and let's see what happens. So notice that this picture actually looks exactly the same as this picture, except for these outlines that are in here. So this is really reflecting the sort of like a proportion within that bin that are of that sex. This is often not how we want to compare these things, although occasionally it is. Another thing to point out is that we can change the color of the bars, not mapping a variable to color, but just overall changing the color of the bars or the outline by setting the color or fill outside of the aesthetic. So here we would just put it inside geom histogram, not inside of the aesthetic. If you want to know more about colors, I have a link to a website here. I'm going to go ahead and just choose one I know. So if I do color, I think this is a color. Dark blue. Notice this is just outlining the bins. So for example, some people like outlining these bins in white so that you can distinguish them. I like to do that some of the time and don't other times. Another color I think is light blue. So maybe we'll try to fill with that. We could fill and color it white. Now notice this is not inside of the aesthetic because we're just setting this. Okay. Moving on to box plots. Box plots are an easy way to quickly compare distributions of a quantitative variable across different categories. They do not show a lot of detail, but are a great starting point. So below, let's compare the body mass for 3 different penguin species. So let's take the penguins data and then ggplot it. So on the x-axis, we'll put species, oops. And on the y-axis, we will put body mass in grams, oops. Sorry about that. And then we will do a geom box plot. Okay, so we can see the different distributions for the 3 species. This middle line, in case you're unfamiliar with box plots, shows the median. The bottom of the box is the 25th percentile. The top of the box is the 75th percentile. And you can read more detail about the lines going out. I think that's good enough. Visually, it can be easier to make comparisons if we put the quantitative variable on the x-axis. So I'm going to go ahead and copy and paste my own code. And now I'm just, you don't actually have to write these in order as long as you've named them. So I'm going to put species on the y-axis and body mass on the x-axis. And if it bothers you to have them written in that order, you can change that. I think this way it's just a little bit easier to compare the medians and see how different the boxes are. So after plotting, we should make note of the differences we observe. So I can see that the chinstrap and Adelie, I don't know if I'm pronouncing that correctly, species weigh much less than the Gen 2 species. And the spread, this interquartile range, the third quartile minus the first quartile for the Gen 2 species is larger than the other two. Sometimes we want to look at how distributions are different across a quantitative variable. When we do that, we need to make that variable a factor. So let's look when we try to look at the variation in body mass by year. So take the penguins data and then ggplot it. So I'm going to put, in this case, since we have year, we want to keep that on the x-axis. You always want time on your x-axis. And on the y-axis, we'll put body mass grams, and then add our box plot layer. So if I just do that, it doesn't seem like it's doing the right thing. And it says, did you forget a group equals? That would be one way to do it. Or we can make year a factor, which means it turns it into a categorical variable. So here we can now see that it's done this correctly. Notice, by the way, that I'm saving my file as I go along so I don't lose all these changes. Okay, moving on to bar plots. Bar plots are most often used to show frequencies of different categories of a variable. Let's first see how we can create a bar plot to count the number of penguins on each island. So let's take the penguins data and then ggplot it. And on my X aesthetic, I am going to put island and then add the bar plot layer, which is one of the ways is gmbar. Great, so this is giving me the number of penguins on each of these islands. By default, R will put these in alphabetical order. In this data set, that also happens to be the frequency order. Unless the variable has an ordering like age, year, etc., it's helpful to put the bars in descending or ascending order. I'm going to show you an example of that in just a moment. We can also make the bars go horizontally by putting the categorical variable as the y aesthetic instead of the x aesthetic. So if I just hop back up here real quick and change that to y, it's now going to create a horizontal plot. I tend to like these better, especially when you have long names. This can be an easy fix. Let's go ahead and keep it this way for now. Okay, sometimes we want to create a bar plot of already summarized data. Below, I've created a new data set that computes the total pounds harvested to date for each vegetable. I saved this as a new data set called summary_veg. So let me run this code. And if we hop over here and open summary veg, you'll see that now I just have for each vegetable the cumulative harvest in pounds. Let me close some of these things. Okay. So now I want to create a plot where the bar is the length of the cumulative weight, and there is a different bar for each vegetable. So in this case, I already have both the x and y. So I'm going to use a slightly different function. So first, let's take summary veg and then ggplot it. So in this case, I'm going to give it both the x and y aesthetic. In x, I will give it vegetable, and on y, I will give it cum harvest pounds. And then I am going to add a geom col layer. You use geom col when you have both X and Y. This is okay, but I can't see the names of the vegetables, and it's difficult to tell which vegetables have greater harvests. We can solve the first problem by putting the graph horizontally, so switching the X and Y aesthetics. We can solve the second by reordering the vegetables according to weight rather than name, using factor reorder. Okay, so let me do both of those things. So let's take summary veg and ggplot it. On the X aesthetic, so I'm going to do the opposite of what I did here. So on X, I'm going to put cum harvest pounds. And then on the Y aesthetic, I'm going to put vegetable, but I'm going to put this reordered vegetable. So I'm going to use a function, factor reorder, and I'm going to reorder my vegetables by their cumulative harvest in pounds. Make sure I got my parentheses right. And then we'll add a geom col layer. So this is really nice and informative because I can easily see which are my sort of top yielding vegetables and which ones don't yield so many. I can tell you that strawberries actually had a lot more. I just ate them before weighing them. Okay, so those are the 5 plots that I wanted to talk about today. The other thing I want to do is give you a few more helpful tools. There are so many ways our plots can be modified. So this is just getting you started, just scratching the surface. One of them is fascidine. This is a helpful way to look at separate graphs for each level or value of another variable. Let's look at the distribution of body mass in grams by sex for penguins. So this code looks much the same as the code I used above. I'm going to still fill in the color by sex just because I think it looks cute. And then I'm adding this facet layer. So I use this function called facet wrap. And then inside of here, inside that vars function, I'm telling which variables I want to facet by. So here, there's a different plot for each sex. We can also specify the number of rows and columns to use in our plots. And we can set the y-axis to vary for each sex using a scales argument. So let me go ahead and show you that. First, I'm going to copy this code and paste it down here. So the couple modifications I want to do are inside here. So a little trick, when you type commas, then push tab, it will tell you all the arguments in here. So in this case, I'm just going to tell it to use one column. That will force it to have 3 rows because there's 3 different plots it's going to create. And then the other thing I want to do is change the scales. And my options are fixed, the default, so they all have the same. And then I can do free all, free X, and free Y. So in this case, I'm going to do free Y. Now, we could probably make this look even better, but for now, that's fine. Notice that doing them this way allows us to compare these distributions better than we could before. I can really see that, in general, the females weigh less than the males. We can also use fascidine with the veggie data. So I could look at, remember that line plot we made that had so many lines on it? I can facet that plot so that I have a separate plot for each vegetable. So let's take that summarized vegetable data by date and ggplot it. On the x-axis, we'll have date, and on the y-axis, we'll have whatever I called it. Nope. Okay, let's take a look at that data set. I don't remember what it was called. Oh, it was just called weight. Oh, right, these aren't the cumulative weights. These are the daily weights. And I'm gonna, oh, mistake I make all the time. I'm gonna add a line. And then I'm going to facet. And I'm going to facet by the vegetable variable. If I wanted to, I could also still color by vegetable. Sometimes that still looks nice. Right. Now, some of these have very few measurements in them, which is why I'm getting this little message up here. And there's still lots of vegetables. So I might want to do some work to like get rid of this legend, which we can do, seeing the names are already up here. I'm going to skip that step for now, but just believe me when I say for now that this plot looks better than having all those lines on top of it. Okay, labeling plots. We often want to give our plots better labels, especially when we've created some variables or used something like factor reorder in the ggplot code. So let's modify this bar plot code. So I'm going to add a labs argument, and this, you can already see the different labels we could give. So maybe we make a nice title that says, let's see, cumulative harvest for each vegetable. That's going to be my title. You could make a subtitle. Sometimes I'll make a caption, especially when I'm using someone else's data, and I might put something like data from, and then have some sort of URL to where I got it. And we can label our y-axis and our x-axis. So for the y-axis, I'm actually going to skip labeling it. And to do that, I can just do quotes without anything in it. I don't think I actually need to put vegetable on here because that's already in my title. And on my x-axis, I will put weight and in parentheses LB for pounds. And if I run that code, I think we'll all agree that this looks nicer than it did before. Changing themes. This is getting to the fun stuff. Themes allow you to change the non-data elements of your graph, like background color, font, etc. You can create them on your own, or you can use one of the built-in themes. I'd recommend starting with one of the built-in themes, and then you can always start modifying these things as you learn more. So my personal favorite is theme minimal. So let me go ahead and add, oops, theme minimal. So that'll change it just for this graph. I like the look of this. I think it looks sleek. Because I like it so much, I like to set my theme for all my plots throughout my document. So if you go way back up to the top here, you can see that here I have it commented out now, but I can uncomment. This theme set, theme minimal will make all my plots with theme minimal theme as long as I run this piece of code. So I'm going to go ahead and comment it out for now just so it doesn't mess things up later. But that's something that I will typically do in my documents. The other thing I would highly recommend is installing and downloading the GG Themes library. There are many different themes in here. So there's some from well-known publications. So for example, maybe you read The Economist and you really like how their graphs look. You can change to the Economist theme. Not a big fan of that one, but there is a Wall Street Journal theme, right? So I'd highly recommend playing around with some of these. Find something that looks appealing to you. And, you know, perhaps someday create your own. Okay. I realized that I forgot to add this topic, but one thing I wanted to discuss was changing colors of aesthetic variables. So let me just find a plot in here. Let's go ahead and use this one. Maybe you don't like this set of colors, and there might be good reason not to like this set of colors. It may not be the most appealing for colorblind folks. So we can change this using a scale argument. So I'm going to change the color scale, and there's all sorts of different options. But one of my favorites is called Scale Color Viridis. And this is colorblind friendly. So we'll do this one. D is for discrete, meaning categorical. So this just gives me a different color scale than I had before. So you can see these have sort of purples, blues, greens, and yellows as opposed to the old scale. Okay. That brings us to the conclusion of this demonstration. I hope it was helpful, and I look forward to seeing you soon.